On this question, it's kind of similar to question number 1 on the review packet. We have a mid-segment, which connects two midpoints on a triangle. So MN is what we call a mid-segment, which best describes the relationship between MN, the mid-segment, and AC. I know they run parallel to each other. So I know that C is true. And I also know that a mid-segment is equal to half of that parallel side. So in this case, MN is equal to half of the parallel side would be AC, right? Right. So then A is also true. Okay. Well, just like MN is half of AC, if I were to double the length of this mid-segment, MN times 2, that should give me the length of AC. That makes sense. So I guess the real answer is all of the above. Question 42. What is the value of X? All right. So I know that this is an exterior angle. And I also know that these are what we call remote interiors. Remote interiors. And what we've learned is that that exterior angle is equal to the sum of the remote interiors. Sum of remotes. So that means that 4x plus 25 is equal to 2x minus 5 and 3x added together. That's what sum means, right? Add them together. So I'll do a little bit of algebra, but first I need to combine the like terms on that right side. I've got a 2x and a 3x that make 5x minus 5. So now I need to solve it for x. That means all my x's on one side, so let's subtract 4x to get them all on one side. I'm left with 25 equals 5x minus 4x, it's just x minus 5. And then I need all my numbers on the other side, so add 5. And 30 equals x. So what's the value of x? It's equal to 30. Now be careful, because sometimes the question will be like, hey, but what's the exterior angle? So you'd have to like plug it back in. But in this case, it just asks for x. Next question. This one also wants to know what its x is. There's a very easy way to answer this question that requires very little work. I know that this is the mid-segment of a trapezoid. The easiest way to answer this is knowing that this answer is directly between the length of the bases. Okay, it's like the middle, the midpoint or mid-segment is what it's called, right? So if it takes me adding 3 to go from 10 to 13, then guess what, dude? I'm going to add 3 more. Boom. So I know that x is equal to 16 centimeters. All right, if you're a formula person, I know the mid-segment of a trapezoid is equal to base 1 plus base 2 divided by 2. So you could have done that and then filled in the blanks and been like, dude, my mid-segment's 13. Dude, my base 1 is 10. I don't know what base 2 is. Over 2. And then you'd have to solve that. You'd start by multiplying by 2 on both sides. Okay? So 2 times 13 is 26 equals 10 plus B2 or base 2. Minus 10 on both sides, so we figured out that base 2 should be equal to 16. So that's the algebra-y way to do it. I like the counting way. Took me adding 3 to get to 13, so add 3 more to figure out what that other segment is. Question 44, what is the midpoint? All right, very similar to what we just did. With the mid-segment, midpoint, they're kind of the same thing. So to find the midpoint, I know the formula is the midpoint, there's my sign for midpoint, is equal to x1 plus x2 over 2, comma, y1 plus y2 over 2. Add your x's up, divide by 2. Add your y's up, divide by 2. All right, so if you like labeling things, I'll label that x1, y1, x2, y2. Good habit to get into. So I've got negative 2 plus 7 over 2, comma, 5 plus negative 3 over 2. All right. Negative 2 plus 7 is 5 over 2. 5 plus negative 3 is 2 over 2. So my midpoint is going to be 5 halves, or 2.5, comma, 2 over 2, which is 1. There's my midpoint. Looks like answer choice B. On 45, if M is the midpoint, all right, of Ln, and this is an endpoint, and M is a midpoint, I could use the same formula, which said x midpoint, comma, y midpoint is equal to x1 plus x2 over 2, comma, y1 plus y2 over 2. I can use the same formula, but I'll have to do it piece by piece. So L is the endpoint, so we'll call that x1, y1, but this is the midpoint, so we'll call it xm, ym. You don't have to do it. I'll show you another way in just a minute, but some of my students like algebra, so I'll show the algebra. X1 is, okay, so I'm gonna do it piece by piece. I'm gonna say the x midpoint is equal to x1 plus x2 over 2, and the y midpoint is equal to y1 plus y2 over 2. So this is gonna say that the x coordinate for the midpoint is 1. The point L has an x value of negative 3, and I don't know what the other x value is. I'll have to figure that out. So to do the algebra here, I'll have to multiply by 2 on both sides. So I have 2 equals negative 3 plus x2. To undo the minus 3 there, add 3 to both sides. And I have 5 equals x2. So I know right now that my answer is B. I can do the same thing with the y's. I know the y coordinate of the midpoint is going to be negative 2. y1 is 4. I don't know y2. All over 2. Solve it by multiplying by 2 on both sides. That's negative 4 equals 4 plus y2, because it was canceled out. And subtract 4. That gives me negative 8 equals y2. So I know that B is the best answer. That was a lot of work. If you didn't like that, watch this. I'm going to draw it. Segment is Ln. M is the midpoint. Tick marks to show that M is the midpoint. Coordinates for L are negative 3, 4. Coordinates for M are 1, negative 2. Coordinates for N are I don't know and I don't know. So check this out, kind of like I did with the trapezoid. How do I do the x coordinate? How did I go from negative 3 to 1? Well, you added 4, right? Negative 3 to 1, we added 4 to get there. So guess what, my dude? Add 4 more. So from 1, add 4, you get 5. Do the same thing with the y coordinates. How do I go from 4 to negative 2? Well, I subtracted. How many did I subtract? I subtracted 6. So guess what? Subtract 6 more. So negative 2 subtract 6 is negative 8. So there's a visual way to do the same problem. How many lines of symmetry? Oh, all right, lines of symmetry. How about there? How about there? How about, oof. Hey, how about between every pair of opposite vertices? How about between every opposite side? I think I'm done. So it looks like a total of, let's see, I had 1, 2, 3, 4, 5, 6. I already did that one. So it looks like 6 lines of symmetry in the sky. Alrighty, we're gonna complete this proof. 1, 2, and 3 are interior angles, and the exterior angle is angle 4. What's my reason for statement 1, which says measure of angle 1 plus 2 plus 3 equals 180? Well, that's because it's all inside the triangle, right? You know that all three angles inside of a triangle add up to the magic number. So we call that the triangle sum theorem. That's G. Triangle sum theorem. Where is it? Right here. Beep. All right, so that one's used. The next line says 3 and 4 are supplementary. How do we know 3 and 4 are supplementary? Well, because they form a linear pair. So that's going to be A. All right, so now that we know they're supplementary, what's supplementary mean to you? Supplementary means that they add up to 180. So them saying, hey, it's 180. So going from supplementary to equals 180 is because you know the definition of supplementary. So GAD. So measure of angle 1 plus measure of angle 2 plus measure of angle 3, we know that those add up to 180. So we replace the 180 with angle 3 plus angle 4. So when you replace something, that's called the substitution property. So that's F. And then it looks like something disappeared. Angle 3 disappeared from both of these guys. We subtracted the measure of angle 3 on both sides. So that's going to be the subtraction property. So GADFS is what we're looking for there. GADFS. Number 48, which value of x makes the lines parallel? So if these are parallel lines, then these would be same side interiors, right? Same side interiors. So they'd have to add up to 180. So let's see what x value would make those add up to 180. 4x plus, minus 5 plus 5x plus 5 need to have a sum of 180. Combine your x's, 9x. Negative 5 and 5 make 0, equal 180. So I don't need that. Divide by 9 and x equals, looks like 20. So what value of x works? That value of x works. If x is 20, then these guys would make a supplementary 180 degree pair. Cool beans. And question 49, the very last question in this set. Determine which, maybe it's like which of? I don't know. All squares are rhombi. That's true if you think about your quadrilateral, I don't know how to spell. Quadrilateral family tree. You had the parallelogram family. And in the parallelogram family, you had the rectangle, you had the rhombus, and then below those you had the square. With their powers combined, you have a square. So are all squares rhombi? Yeah, dude. All squares are rhombi. All squares fall under the rhombus category. So that's true. Are all parallelograms rectangles? Are all of these those? No, some are rhombus and some are neither. So that's a false. All kites are quadrilateral. Yeah, kites would come over here in the quadrilateral family tree. Traps would be here. So yeah, all kites are quadrilaterals. And all trapezoids are parallelogram. That is never true. Trapezoids are on a whole different branch of the tree. So 1 and 3 are correct. Boom.